Hello. Through this presentation, we hope to prove that this Pythagorean identity, sine squared of theta plus the cosine squared of theta, is equal to 1. For the purpose of this demonstration, we have decided and determined that 1 shall equal 5 of these squared tiles. So we have beforehand determined that this is equal to 1. And we have created a string compass that is equal to this distance, approximately. So using this compass, we will create a circle. A circle is determined by all of the points that are equally distant from its center point. There we go. And here is where the pin was. Using a straight edge, we can now bisect this circle. And we know that the radius of this circle, or the point from its midpoint to its outer edge, is a unit of 1. Now I will create a perpendicular line. With these 2 points. Ooh, is a little bit off. There we go. And this will now serve as the midpoint of a new circle, which we will now call our unit circle. Ooh. We now know that these lines are perpendicular and form a 90-degree angle through our compass construction, and that the radius of this circle is equal to 1. Now we will drop a line down from a point of the outer edge of this circle to form a triangle. We have decided that we want a side length of 3. So we will use these tiles to measure a side length of 3 units. So somewhere about there. I will now use a compass to draw a perpendicular line. Whoop, about there. Whoop, about there. Oh my word. Okay, there we go. We now know that these two lines are parallel and that both of these angles are right angles. We will determine that this point will be the point theta, and our point of interest, our angle of interest, and we will draw a right triangle. Because we have determined that this is a side length of 3 units, we will now measure this side length. To be a measurement of approximately 4, almost. Through Pythagorean theorem, we know that a squared plus b squared should be equal to c squared. We can then also say that this side shall be called x and this side shall be called y, and set them over 1, and they should still be equal to x and y, and can therefore be called cosine of theta and sine of theta. Using Pythagorean theorem, we know that the square of one side added to the square of the other should be equal to the hypotenuse of our triangle squared. Almost there. One more row. So sine of theta squared, which in this case is 3 by 3, plus the cosine of theta squared, which in this case is 4 by 4, should be equal to our hypotenuse. So if we set these tiles equal we will realize that when we add them up, we have the sum of the hypotenuse. So we can say that cosine squared plus sine squared of theta are equal to 1, as we have determined that 1 is equal to 5 tiles. And 5 times 5 is 1 squared, which is equal to 1.